Hello, everybody. This is this week's report for the Firebot project, which is Group 6. So just some quick notes that we went over during the team. The first thing that we did was we took inventory of all the parts that we ended up getting on Tuesday. So that included like our chassis, our servos, that kind of stuff. So we took inventory of that. After that, we were able to check in our servos and sensors, make sure that they worked. We were able to update the progress flow chart, continuing with that, finish building the microcontroller. And then lastly, we wrote the second and third sections of our final report. So as far as the updated progress chart goes, as you can see, it got a little bit longer from last week. The main takeaways from this week were that we started working on coding, we started working on the fan that would be used to blow out the fire, and then we started building and actually completed the building on the chassis. Additionally, we were able to continue work on the final report. So as you can see, some notable areas, completed the report section 1, completed report section 3, completed programming of the ultrasonic sensor, and then also done was that we built the chassis. So added a couple other things there, but basically kept on keeping on. The microcontroller update included wiring, coding sensors that our bot is going to need on there. We are currently attaching sensors and attempting to compile data on the microcontroller. And then the first experiment that we're going to run with it is the ultrasonic distance sensor. And there is a picture of the current status of the controller as it stands right now. As far as coding goes, we had a pretty big leap in progress for coding. In addition to actually testing all the different devices, we were able to get pretty accurate values for all of them. We tested both sensors, including the infrared and the ultrasonic. We tested our LEDs to make sure they were working right. And then we also started our code for the omnidirectional servo. So as you can see on the screen, there's a servo right there that's sitting in a 3D printed piece that is attached to another servo. This basically allows it to move in basically like a 180 degree field, which is exactly what we wanted to. So. And then the cooling fan update. So the thing that we're actually going to use to blow out the fire on top of this vehicle will be this cooling fan. So this first preliminary design was using this quick small fan, but we were actually able to build one in SolidWorks, like a CAD software, and that's what it looks like. We could 3D print a lot of the parts for that. So it kind of just depends on where we're at with time, whether or not we're going to do that. Additionally, we were able to complete the second section of the report, which was the microcontroller. For input and output requirements, we had 2 inputs, which included the ultrasonic and infrared sensors, and our outputs included 4 servo motors and 2 LEDs. The 4 servo motors are the 2 drive motors that you have in the chassis, and then those 2 servos that we use for that omnidirectional like arm-like thing that I showed earlier in the coding slide. Our microcontroller was given to us as the Mega 328P, and that's what we're going to go with since it works for all of our needs. The programming language that we're going to be using is the Arduino language, which is like a modified C++. The rest of this report included a lot of other stuff, but it wasn't the stuff that we were necessarily ready to do. Like it talked about a lot about like how you were going to code it, what was the pseudocode like, and then a bunch of other stuff about the microcontroller. And it's just way too early in the project to be determining that. So we're just gonna finish that section of the report as we get there. The third section of the report is the ethical and professional responsibilities for us. Obviously, for the global responsibilities, this product can be used around the world to help put out fires. Since we have the treads on it, it can be used in a lot of different terrain. So it's not like limiting to one spot in the world. Economically, it can save companies a ton of money. One different alternative use that we thought about this bot was that it can find hot spots in machinery and actually cool them down with the fan. So even if we weren't able to get like an actual water-based system running, it would work for the fan, like cooling them down like that. And then environmentally, it's obvious that it's going to benefit the environment by stopping fires. So that's how we're affecting that. And then our plans for the next meeting is that we're going to meet up next week on Thursday to come together and continue this. We are going to put together our parts, building the robot. We're going to keep making sure that the microcontroller will work and then actually code it and put it together with components. And lastly, we'll develop code to work with the sensors, servos, and LEDs to kind of all compile it together. So making a lot of progress in that. As you can see in that slide, there's a picture of our chassis as it stands right now. So last week I showed you a picture of what it looked like online. This is the kind of product of what we got right now. So making a lot of progress. I will talk to you guys later.